physics department research faculty is composed of biological and biomedical physics, nanophysics or nanomedicine, and condensed matter physics, particle physics and astroparticle physics, both experimental and theoretical. And we have network science theory that's really probably one of the best programs in the world.
I took a bunch of core classes my freshman year, and what really grabbed me about physics was when I was attending the Society for Physics Students meetings and hearing about all the undergraduate research that was going on, all the cool co-op opportunities that the students had, both on campus, well also in Boston, but worldwide too. There were students doing international research, which I thought was really neat.
Most students come here because of our well-established and successful co-op program. We take it very seriously. Because of that, Northeastern invests significantly to help prepare the students for co-op and beyond.
I go to the big accelerators around the world and study the interactions of particles at the highest energies available. I teach undergraduates, and I also work with undergraduates in my research.
Very few schools offered the amount of research and the availability of the research that Northeastern offered to undergraduate students even at a freshman level.
I have a new undergraduate working in my lab, Patrick Wong, who has been working in computational material science. We also use dynamical system theory to predict the complex behavior of materials under large forces.
When you come in freshman year, you hear other kids taking quantum mechanics or particle physics, or one of these upper level classes that seem like it's just totally unapproachable to you at that time. But the program just kind of takes you through step by step, just giving you all those building blocks of what you need. And then when it comes time to actually take these quantum mechanics classes, it just sort of falls out nicely.
Our nanomedicine effort, which is funded by the National Science Foundation through a very large training grant, applies nanotechnology to the key problems of modern medicine.
Well, my experience here at Northeastern has been quite varied. I've had a chance to do a lot of different things. I'm working now on characterizing titanium oxide nanotubes. It's part of the main goal of the lab, working with these nanotubes, finding different electrical, optical properties for more applications.
We have in the undergraduate physics courses called modern physics. And this is sort of an introduction to all the revolutions in particle physics that took place in the 20th century, beginning with the discovery of quantum theory and of the nucleus, and then later on the discovery of quarks. So this is actually a very nice course which will excite them to go on and learn more about this field and about this nature of the universe.
If an undergraduate is interested in doing research with me, there are various paths, but we have a biomedical physics major that the students can do, which prepares them, teaches them most of the physics, general physics curriculum, but also prepares them for working in biological physics. They learn some of the biological aspects of physics with specific courses.
What's very nice about this place is that it's not only a diversity within the field of complex systems and network science, but it's also a diversity of cultures who are here. So, I was born in Brazil. We have people from Israel, China, Korea, India, Italy, the US, of course, and I think this is super enriching in a cultural sense.
Being at Northeastern is the perfect place because it's a campus, but it's in the city. You still very much have the cohesive campus feel, but you're right in Boston.
We have high quality, highly motivated students who will just jump in and get things done.
It just kind of wakes you up. It's very energetic. When you see people walking around, you see T's flying by, and it's hard to be tired. It just wakes you up, and it's kind of like drinking a coffee.